Hello friends, so today we are solving this problem, zero array transformation 3. Okay, so this is the third part of same question. So you are given an integer array nums of length n and a 2D array of queries. Queries has the range kind of a start and end point, so it has only two values like that. So each queries I represents the following action on the nums. So decrement the value at each index in the range LR in the nums by at most 1, not more than 1 or 0. Okay, the amount by which the value is decremented can be chosen independently. We are free to choose when we should decrease by 1 or when we have to leave it. So we have to convert this nums into a zero array, okay, using these queries. Now the thing is, we have to return the maximum number of elements that can be removed from these queries, and still we can convert this nums to a zero array using the remaining query. So what it means is, like, you can take an example of this. So this is our query and this is our num. So now we have to convert it into the zero array. So how would we do it? So for example, if we are taking this guy 0 2, right? So index 0 1 and 2, all of them are included. So what we can do here, we can make this operation, so it is including this. So I can decrease this guy by 1 because it is a 0 index, 1 index and 2 index. So all of them are covering into this range. So this range is our 0 and 2. So that means we can decrease all of them by 1. So we can make this as 1. Okay, and this is already 0, so we are not decreasing it, and then we can make it this also 1, right? Now we have this guy 1 1. Okay, so 1 1 has a starting 1 and ending 1, right? So we cannot do anything here. Similarly, still we have 1 0 1, right? 1 0 and 1. So now still we need to decrease the first and the last element. So if we are taking this guy, this is also having same range 0 and 2, right? So everything between 0 and 2 can be decreased. So we can decrease it by 1, so this would become 0. This is already 0, so we are not decreasing, and this guy is also decreased by 1, so this also would become 0, right? So we are able to make it zero array. But the thing is, we used here, we tried all of them, right? But if we don't try this guy at all, using these two itself we can still make it, because at this point we didn't use it at all, right? So if we use 0 2 and the first element and last element, right, 0 2 and 0 2, then also we can make it 0 0 array, right? So for that reason, what we can do is, if we remove this guy, if we remove this query at all from here, still we can convert it into the zero array, right? We did it 0 2, and one more operation, it would become 0 0 and 0 using this 0 to 0 2, right? So we are able to make it. So now we can say that we have removed one element. So removing by the one element, we are still able to make it. So the thing is, how many maximum elements we can remove from this query so that we can still make it, convert it into the zero array. So here, if we remove this guy, we can convert with the help of these two. So we have to remove the maximum number of elements. That means we have to manage with the minimum number of elements which are existing to convert them into the zero array, right? So if we minimum number of queries if we use, then the remaining would be removed, right? So that is why we are looking for the maximum removal of it. So what would be the approach? So let's take this example for the approach. So far we know that what we are supposed to do, but now we will know how to do that. Okay, so this was it was 1 1, right? So it was 1 1. So the approach here is, because we are starting from 0 index, right? We are starting from 0 1 2 like that. Okay, so our intention is, we have to find such intervals. Okay, we have to find such intervals which are covering these indexes, right? For example, if we took this 0 2, this guy 0, and 2, it is covering for this index, right? I equal to 0. So we have to get first of all those things which are having the range that I should be in between the range. Okay, so we are supposed to do in that way. Now because we are starting from 0 to increasing way, so what we are doing here is we are going with one grid approach. That grid approach is, let's sort this query array based upon the first element. Okay, so if we sort the this array based upon the first element, how would it look? It would look like, okay, now after sorting, what we are supposed to do is we are starting from here. Okay, in the nums we are starting from I equal to 0. Okay, for every element we are starting. So at I equal to 0, what we have value 2. That means at least 2 intervals should be there in this query which are covering to 0, right? 0 index. So see here, this guy 0 2 is covering to 0, this interval also covering, correct? So then only it is 2 times would be nullified, right? Because our intention is to make it. So to nullify it, we need the 2 operation, correct? And 2 operation we can find here. So as we have already sorted based upon the first element, now our next target is we have to find the such ranges which are covering as much as possible to every index. Okay, and how do we do that? So if we go through this, if we create a priority queue, okay, this priority queue would be of the max heap. Basically the largest second index should be on the top of it. So if we create a priority queue, and when we are starting from I equal to 0, we are taking all those values from these queries which are like in the range of it. Okay, for example, here is the 0. So any value which is small, a start value is lesser than or equal to 0, all those second value we will put into the priority queue. For example, in this case, let's say this is our priority queue. So what would we would have done is we will come here. So 0, which is less than or equal to this I, because I is 0 and this start is also equal to 0. It should be either lesser or equal to I. Then what we will do, we will take this second value into priority queue. So we would add it like this. Now again we will go to this value, that hey, what is the first value? First value is 0. Is this a lesser than or equal to I? Yes. So we will add this also into the priority queue. This value, second value 2, right? Now we are coming here, that hey, the start value is lesser than or equal to I? No, this is 1 and I is 0. So we will stop here. So for now, this priority queue would be having these 2 values. Now we will keep on popping out these 2 values, right? And we know that the value at nums I is 2. So we need at least 2 operations to nullify this 2 to make it 0, right? So we'll pop it out this guy. Okay, so this is 2, which is a valid range, right? Because it is greater than the I, greater than or equal to I, then only it would be a valid range, right? So so this is a valid range. So we will make operation ops. Let's say we have a variable operation, then we will increase it by 1. So as of now it would be 1. Now we will pop it out. Now we will again go to here. So top of it again there is a 2, which is again greater than or equal to this I, because this is the last range of it, right? So we will pop it out. This guy will be also pop out, and we will increase this operation equal to 2, because we are increasing it by 1 or plus every time we are doing. Okay, so in this way we have got this ops equal to 2. Now we will keep on going. We will come to this guy I equal to 1. So we will again go in the same way. We will check this guy is smaller, so we cannot add. This guy is also smaller, we cannot add. This guy is greater equal to, right? So in this case what will happen, our I is 1, right? So we would this would be eligible. So in priority queue we would add the second value, which is 1. Okay, now similar way we will again check. We will pop it out this way, this guy which is 1. So it is less than or equal to 1, right? I. So this would be operation would be another plus. So operation would become now 3, right? So in this way we would keep on increasing this operation. But one more thing here is we will create an array, just like we do in the case of this thing, you know, line sweep algorithm. We create an array to keep track. Let's say we are calling it diff array. Okay, so in diff array what we will do is basically initially it would be this diff array would be of the size n plus 1, whatever the size of this guy plus 1. So initially it would have 0, right? But whenever we are ending at the any of these interval, whenever we are ending at the end plus 1 index, we would be keep on decreasing. You know that in line sweep algorithm to nullify the this thing to nullify the prefix sum, we keep on decreasing for the out of range index, right? So in this case what will happen, like here when we came first time 0 to 2, right? So at third location we would decrease it by 1. Again we would coming to this guy, so this would be decreased by 2, right? So in this way basically we have to decrease it the index plus 1, the last index of the range plus 1. That index we have to decrease every time, because later we will do the prefix sum, so that we will nullify that effect. Okay, so in this way we would be keep on doing. And finally what we will do whenever we are doing this priority queue operation, right? So we will check every time once we are done, let's say for I index we are done, so we will have ops equal to 2, right? Total 2 operations we made, right? So when we are finding this ops equal to 2, we will check that is this value is smaller than nums. If it is smaller than nums, we will immediately return -1, because in that case we are not able to make it 0 at all. Otherwise we will keep on going. Okay, and finally whatever is remaining in the priority queue, those are the intervals which we don't need. So that size, whatever remaining value in the priority queue, that size, that numbers of the operations we can skip from this query operation. So let me show you my corresponding code for it, which will make it better sense. So see here, I have created one diff array, right? Like we do for this line sweep algorithm. So this is the length of my nums, then I am creating n plus 1, because we have to put that extra count, right? So see here, this is the priority queue, which is a max heap. Remember, this is a max heap, not the min heap. Now we are sorting here this queries array. This queries array I am sorting based upon the first element of the query. Okay, so we are sorting it increasing order of that. Now what is happening over here is we are traversing through this nums. Okay, we are also creating one variable j, which would be used here. So see here, ops variable initially it is 0. Now I am doing this ops equal to ops plus diff array. Initially diff array has everything is 0, but remember when we are doing the this line sweep algorithm, this would be same concept is being used. Now see here, while j is less than queries dot length, this is just a check of the length, and queries first element is lesser than or equal to the I, just the way which we were doing here, right? Then only it would be fall in the range. So for the same reason we are checking if it is falling in the range. So any number x is in the range if the start point is lesser than or equal to it and end point is greater than or equal to it, right? So for that reason I'm checking that if start point is lesser than or equal to I, we are adding that into priority queue, the second value. You can see here 1, right? 1 means the end value of this range. So this is the first value, this is the second value. That is why I have taken it queries j and the 1. So second value we are adding into priority queue, and we are increasing j by 1. Okay, so till the j is less than length, we are keep on doing this for every index I. Okay, so now once we are coming out of this while loop, we have all the values which might be in the range. I am saying might, not necessarily that everything would be in the range. Okay, so why I'm saying this is like, for example, let's say our I equal to 4. Okay, so I equal to 4, then anything which is starting at 3 is also valid. Okay, anything which is starting at 2 is also might be a valid range. But what if it is ending at 3? Then this 2 3 might not be a range for I equal to 4, right? So for same way, initially what we have done is we have taken all those which are smaller value in this while loop. Okay, and their corresponding ending value we are putting into the priority queue. Now in the second while loop, what we are doing, till the time our operation is less than num psi, because we have to do up to num psi operations, right? And till the time it is not empty. And see here, when priority queue top, okay, because this is a max heap, so top of it is should be greater than or equal to I, okay, so then only it would be a valid range. So what we are doing, we are increasing the number of operations. And see here, this is an important thing. In the diff array, every time wherever we ended, right, this is the pq dot remove, okay, because these are the priority queue has the end range, right, end value of the range. So that end index plus 1, we are doing it decrement by 1. Why? Because when we do the prefix sum, at that time we have to nullify, because we are summing everything at this step. At this step we are summing everything. So those who are out of range, we are doing it minus minus, so that this would be effectively give the equivalent operation actual required. Okay. So when we are coming out of this while loop, so here for this every index I, okay, we are coming out of it. And now here we are checking that, hey, even after doing for all the operations, if this ops is still less than num psi, that means we can never make it equal to 0. So there is no point of further check. We are immediately returning minus 1. Otherwise we will keep on going for every index. Okay. And see here, finally what will happen, I am returning here return pq dot size. Why? Because whatever is remaining in the priority queue, that is of no use to make it 0. So those many numbers can be removed from this query array, right? So that is why we are returning this as an answer. So what is the time complexity here is, we are taking basically the sorting here, so n log n would be taken here, and we are using the priority queue as well. Okay, so it would be of order n log n. So let me execute this code and let me try to submit it. Yeah, so thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.